Boom, here we go. All right, so research is kind of an interesting topic. And again, I apologize. I'll mention kind of how we deal with COVID a huge number of times in class, if only because it's probably the most significant sort of public health thing that's happened in 100 years. And I'm sure none of us thought we would live through an actual pandemic. But one of the things, as a person that does research myself, as a scientist, that I've been both impressed and frustrated with is sort of what COVID has taught us about how we do research, how we communicate about research to general people. And it has exposed some of the things that we're good at and some of the things that we're not great at in the midst of all of this. Okay. And so I think it also highlights that you guys don't get a lot of training on what research actually is. A lot of people ever. So, and this is gonna function kind of formally today, but more so for the entire class, is we're going to do a little bit of introduction to the scientific methods. Like, what does it mean to do research, right? Like what is actually happening. I can hopefully kind of present to you guys that all of you do research every day. Okay. Every single day. We'll just pick on Erica because her dog was so cute. Erica, my wife would want to know, do you have a skincare regime? Kind of. Okay. My 43-year-old wife would tell you, get one now and stick with it. Don't be like her and wait for a little bit later on. But if you have a routine, how have you arrived at that particular routine, if you don't mind sharing with us?
I guess just like over the years of like seeing stuff and then like stuff that like my friends have used and like trial and error kind of type deal.
Okay. That's research, Erica. That's research. Okay. That is you doing your own research on things. Let me pick somebody else. I'll do another kind of common thing. Who do I see here? Jillian, do you drive to campus ever?
When it's cold outside.
When it's cold outside. Okay. Where do you park?
At my sorority house, and then I walk to the building that my class is in from there.
Okay, well, that's not going to be very useful in some ways to me. Because what I was going to say is, do you park in the same place all the time? And then if you do, how did you decide that was the best place to park? Right? So like, oh, well, I go here or I go there, or when I go to this class, I park at this time. So think of the rest of you who maybe don't have a sorority house at which to park. Or you don't have a faculty spot that you park in unless it's going to like storm outside. And then we see all of you double park your cars in the deck there with everything, which I appreciate. But you do research when you're doing that. Where am I going to park? I went at this time of day. This spot was open. I came tomorrow. The same spot was open at the same time. You're gathering data on, okay, this is a thing that's going to happen. Or I took this path when I was walking because, I don't know, there was the least number of stoplights and crosswalks I had to go by, or whatever it's going to be. Okay. So what I hope you take from all of that is all of us are doing research every day. Okay. When you have a toddler like I do, it is both enlightening and fun, but also completely terrifying. That's all that she does because she has like no life experiences. I climb up on this. Can I do it or can I not? Research. I touch this thing. Is it hot? Is it cold? Is it whatever? Okay. All the things that she does as she interacts with the world for the first time, that's research. That's us gathering data and then using that to inform our future decisions. That's all that you're going to do in class. Okay. When we do formal research, okay, it is very much like kind of all of we won't even call it anecdotal, but kind of practical research that you do. We have a question or a problem, right? What do we need to know? What do we need to solve? And then we're going to go about some sort of systematic way of trying to find an answer to that problem by asking questions, gathering data, testing different things, trying it one way and then trying it a different way and see if you get a different result. So we're gonna manipulate some of these things. And you all do this all the time in your life. Okay. All we're doing is just kind of giving it a little bit more structure and giving it a few more rules or a framework within what it's going to exist in. And then we're going to call that your capstone project. That's all that it is. So in that way, I don't want to demystify research and make you think that it's easy to do it. You can do it badly. Lots of people do it badly. I do it badly plenty of times. Okay. But it's maybe shouldn't be as kind of mysterious and daunting as maybe it is for some of you. Okay. I have no idea where I got this definition, but it's a systematic, controlled, empirical, critical investigation of hypothetical propositions about the presumed relationship between and among phenomena that is both reductive and replicable. And you're probably all saying, Dr. Black, what the fuck does that mean? Okay. And so I don't know if we talked about that on the first day of class. I do curse a fair amount. For those of you that haven't had me before, it's entirely my wife's fault. She's the mouth of a sailor, which has really been kind of a drag for us that we've had to, now that Ellis can talk and mimic us, we have had to really cut that down on those things. All that this means, systematic, controlled, empirical investigation of hypothetical relationships or propositions. All that this is we have a question that we want an answer to, and we're going to have a process. We're going to have a set way of trying to answer that question, right? We want to know, is there a relationship between whether or not you have a certain amount of activity, whether or not you exercise a certain amount, and whether you wanted to get the COVID vaccine, right? That would be a question. And we're going to be systematic and, okay, well, then to do this, we need to put it and ask this question to these people. We need to know this information about how active they are, how much they exercise, where they get in terms of, like, we put all of those things together and formalize it. And then we go out and we collect data, and we're going to have a hypothesis about what we think is going to happen, and we're going to test it. That's all that we're going to do. That's what all of that kind of gobbledygook means. Okay. So the first thing that you guys are going to do is what you've already done. We're going to identify the problem and ask a research question, right? What is it that you want to learn about, or what you want to know? Always keep this in mind. We're going to always come back to this. I'm going to always tell you, well, what's your question? What's the question you want an answer to? Because as you put your surveys together, as you design your particular experiment, when you make certain measures or you get certain pieces of information from people, we need to make sure that that information is going to let you answer the question that you're asking. Because you'll come up with all of these cool things, but then you may ask them and still not have an answer to your actual question. And I will say things like, well, that's an answer to some question, but maybe not to yours. Okay, so that's the first thing that we're going to do. Okay, then we're going to make a hypothesis. We're just going to make a somewhat informed guess about what you think is going to happen. Okay, we're going to base that on your literature review. Okay, you're going to look for stuff that other people have done that is somewhat similar to what your question is that you want answered. And then based upon what they have found, we're going to make our best guess on, this is going to be related to this, right? The amount that you study is going to be related to your GPA in a positive way, based upon these other papers that we've read or something like that. So you're going to state a hypothesis. You all will write formally multiple hypotheses. And you will think, why am I doing this, Dr. Black? Is this not just super obvious? And my answer is yes, of course it's super obvious. Here is your question. Here's what you're going to hypothesize. But the hypothesis has to match up with your research question. We'll get into this more later on. And the hypothesis drives the statistical tests that we're going to run on your data, okay? And we'll spend a couple of class periods talking about stats. For those of you that have had a class in stats, a lot of that will be reviewed and will make a lot of sense. But the hypothesis fits with the question and it drives the stats. And that's going to tell us then, what do we know, or what is the answer to our particular question? So we have to have good hypotheses, okay? But we'll spend a couple of days talking about those, writing those. You guys will write them. I'll give you feedback. We'll write them again. We'll talk about hypotheses a lot. Okay. We'll design your protocol. What are you going to do? Right? What's your survey going to say? What questions are you going to ask? If you do an actual like in-person testing, like what are your measures going to be? Who are you going to test? How are you going to get them there? How are you going to recruit them? What are their instructions before they show up going to be? All of your study protocol stuff. Okay. Then we execute that protocol. You get your data, and we're going to run stats on those data based upon what our hypotheses are. And then we're going to decide were our hypotheses supported or refuted. And then that's going to give us, in some ways, the answer to what our research question was, right? This is what it is. This is what it's not. It was these two things, but not this other thing or something. And you'll write and report about those. And then you'll present some conclusions based upon those results. I think all of this should be very straightforward and very, in some ways, intuitive to you guys, right? You're all very, very intelligent people. I've stalked your previous GPAs from when you applied to the program and everything. I like to know who's in my class and what I'm working with. In the midst of all of this, I will also, when I take over the other Capstone class, I will pit you all against each other as classes to, have the challenge of like, which class will do better on the test, which class will make the better poster or whatever. So I'm not above those kind of petty competitive things. Okay. All right. So this is where we get into some of the gray area. Okay. So, and here's where people like my wife have problems with research. So there are these ideas of, if we have done multiple studies and we've tested the same thing over and over again, and we think that we have some sort of fairly, certain concept or relationship that we have identified, we can form what we call a scientific theory. It is a statement or a set of statements that present some sort of view that sort of codifies the relationships among variables. The sky is blue. Okay. What if it's actually purple? And what we think of as blue is actually purple, and we've just been all hoodwinked or some way. We're all in the matrix and it's the wrong thing or something like that. Okay. And so generally, scientific theories are meant to be much more concrete things. This is the stuff that we think we've settled this, right? This is the stuff that we think we know. Well, the problem is when we do science is we're always in a place where we probably need to keep an open mind, because as technology advances, as our ability to measure new things or measure the same thing in slightly new and more meaningful ways, we may learn things that we didn't know before. And what we thought was a scientific theory now does not become, the theory changes a little bit, or something like that, right? So you can imagine, I always give this as an example on things. There was a time, right, where we didn't know what a virus was. There was a time that they thought you got sick because, I don't know, the person you lived with was a witch or something, right? And you breathed in some bad vapors. Like we didn't know anything. Like we didn't have a microscope. You couldn't see a virus, right? One of my former master's students went and joined the Peace Corps, and he had to went to Cambodia and went out in basically in the jungle and set up places to teach people how to wash their hands, right? It's Cambodia. They don't use toilet paper. So guess what they use? Their hands, okay? And they did not understand or could not grasp the concept that there were things that would get on their hands or in places that were invisible that they couldn't see that would make them sick, right? So for them, what we think of as settled scientific theory, they're just like, what the hell is this? My mind is blown, right? Why are you telling me there are things that I can't see that are making me sick? And if I wash my hands, and I'm not going to get sick. This was crazy stuff to them, okay? So his job was to try and go and convince them otherwise and to show them these kinds of things. And so I say all of that to just say that we're probably not going to be testing any real scientific theories or kind of gaining any sort of truly sort of groundbreaking evidence from what you guys do in class, but we just need to keep an open mind about these things. You all are going to read a bunch of papers, and you may think some of them are wrong. You may think, I don't really, we're not going to get all of them on all of these kinds of things. But the good thing about theories is it provides structure for our current research. We think, to the best of our knowledge, here's what's happening. Now let's try to explain just a little bit more of this little piece, and a little bit more, and a little bit more. And then incrementally, we can build upon all of that stuff. Okay. So I put all of these things on here of things that are going to make for good scientific research. It's going to be difficult for us to completely adhere to all of these things ever, no matter who you are as a researcher. But I just want to kind of present some ideas on all of this because I think it's helpful. Okay, we're looking to investigate systematic relationships. Every question that you guys have sent to me is about some sort of relationship. Okay, we want to look in a more holistic manner. Why does this thing, or does this thing cause this? Is this thing related to that? Okay, we're hopefully going to use our ability to look back in old research to try to figure out how your questions are going to support or build upon existing theories. Here's what we think is going on and what's going to support that. So now let's take it one little step further. Okay, you're going to get empirical data through observation and gathering of data. Okay, that's the really cool thing, right? We're not just going to like make up something like we're philosophers and think on it and think, yeah, I think this makes sense. Okay, I think that this makes sense. One of my wife's favorite shows is The Big Bang Theory. I don't know if anybody ever watched The Big Bang Theory. And one of the characters on there, Leonard, in one of the early seasons, his girlfriend Penny asked him what he did today, and he's a theoretical physicist, and he says, I thought about some things. I wrote some of them down. And my wife always says that to me when I'm doing things. But there are people that do theoretical research. You think about an idea, and then you kind of write it down, but you'll never actually test it or do anything else. Okay, we're not going to do that. We're going to get real data, and we're going to test some things. Okay. Good research assumes that you know what the hell you're doing. It assumes some level of researcher expertise. We're going to kind of use that to our advantage in trying to have you guys look at things that are in the realm of stuff that you've already had in class, in the realm of things that you all have some expertise in. We're going to acknowledge that probably none of us are maybe know absolutely everything about everything that we're doing, but we're not like you guys are that we're going to go study quantum mechanics or string theory or something in the midst of all of this. We're going to try to be objective. We're going to try to have logic in all of this. We're going to try to have you write your questions in a way that you're not going to bias people into answering a certain way or bias yourselves into finding kind of certain things. And so that's kind of what we're gonna do. Let's not worry about inductive versus deductive reasoning. Okay. Let's move into a couple of other things, try to figure out some ideas on what makes for good experiments and good studies, and see if we can work this structure into what you guys are going to do. Okay. I need to check on what Cameron put in the chat on all of that. So I think the first thing that you all need to know and appreciate for your studies, and I'm going to ask you all to write this out in excruciating detail, is independent and dependent variables. Okay. And so the dependent variable is the easy one. This is whatever it is that we're measuring. Okay. This is your outcome variable. And so this is the thing that you're going to measure in the lab, the answers you're going to get, or the questions you're going to ask that are going to get you a particular answer. Okay. So if I'm interested in sort of, let's just say, COVID symptoms and your weight status by BMI, right? Then what we might say is my outcome variable is, my COVID symptoms. Okay. An independent variable is the thing that we're going to manipulate, or the thing we're going to use as a treatment, or in some things, when you do survey research, the independent variable is the variable that you're using to form your groups for comparison. Okay. So let's just say if I'm interested in sort of weight status by BMI on COVID symptoms, I would then I would have independent variables that are weight status. So I would have underweight, normal weight, overweight, obese, maybe morbidly obese. I would form my groups on those independent variables. And then I would look to see, are my COVID outcomes or COVID symptoms or length of time that I had something, are those things different? My dependent variables different based upon which weight category my independent variable that I fall in. Okay. Sometimes we get groups that will want to try to do some sort of exercise treatment or give people a supplement, coffee or caffeine. Or we had a group last year that gave people, oh God, it was some kind of, I think it was tart cherry juice or something like all of that they bought at Walmart. That would also be sort of ways you could look at independent variables. You're like, oh, I'm going to give you the tart cherry juice and see if it makes you jump higher or run faster. Okay. All right. Any questions about all of that? Because I'm going to ask you all today, once we pick your thing, to identify your independent and your dependent variables. Nope, nothing. Okay. Do we all need to get up and do some wall sits to kind of perk everyone up a little bit? I don't know where you guys are at your house there. Cameron has her like background blurred out. I don't really know what's going on, where she is there. Emily may be in a room. Okay. So Emily may be in a study room or something. I don't really know what she's got written on that whiteboard behind her. Bailey's maybe in her room. I don't know. Make you guys like get up and do some jumping jacks and some wall sits to perk everyone up. Okay. So the next little piece here is this idea of correlation versus causation. Okay. And so given what most of you guys had proposed, the vast majority of the questions that y'all are asking are going to lend themselves to things that are more kind of correlational type experiments. Okay. They're more correlational. We're going to look at a relationship. They're not a true experiment because we're not actually going to be able to manipulate sort of your independent variable in the way that we would in some more laboratory-based experiments. Okay. So we can draw some ideas of causation from what we call true experiments, where at least one independent variable is going to be, we're as researchers going to manipulate this. We're going to give you caffeine or a placebo, or we're going to give you 8 weeks of exercise training or not, or something like that. Okay. And so most of what you guys are going to do is more correlational from that standpoint. Okay. So a lot of times those ones are going to use a single group. And we're going to look at a relationship or an association between two or more of your particular variables. All right. You may form groups or have groups that are different on those variables, but you are not specifically going to change them. Okay. And so from that, we have to predict if something can happen, but we can't truly say that there is, in fact, a cause and an effect. Okay. There are very specific kinds of experiments. They're oftentimes called randomized control trials that you may have heard about if we're looking at drugs or things like manipulating exercise training or physical activity levels or something on certain outcomes. And there's some things that go into that. That's how we're going to get the best way at cause and effect. What we're going to do is what most of you guys are going to do is kind of correlational, kind of large scale cross-sectional studies where you're going to gather a group of people and you're going to try to put them into groups based upon some of their inherent already existing characteristics. And then we're going to look and see if sort of those groups are different on some things, which is very good research to do. It just truly can't get us cause and effect. Okay. So I gave an example there, like if we were to sample a group of freshman students and see that gender was associated with height, i.e. that men tended to be taller than women. We're not physically like taking men and women or taking a woman and turning them into a man or vice versa, and seeing if that has some absolute effect on their height, or we're not giving them this hormone or that hormone. All we're doing is just getting this large swath of data and trying to see if we can see some relationships there. Okay. So as I mentioned, with more true experimental research, what we're looking to try to do is have good sampling and selection and assignment types of things, where what we're going to do is get a group of people and randomly pick half of them to do one thing, another half to do something else. Hopefully they're all relatively similar on a bunch of things, and then we see if the group that gets something changes or doesn't, and the group that doesn't get it, does it also change or not change. And that gives us a much better chance to try to see if there's causes and effects. Okay. A couple of you guys had some things where we might need some control groups. A lot of it was kind of survey-based stuff where having a control group is less of an issue. But when you really want to do some sort of experimental research where you're manipulating something, having a control group is really, really important. I cannot emphasize that enough. Okay. So for example, let's just say that we were going to take half of you guys and give half of you were going to come with me every day during class, and we were going to go do some squats or something during class, and we were going to see at the end of class like how much stronger you had gotten or how much bigger your muscles had gotten. Okay. And so the other half, I would want you guys to be our control group, or you would not do squats. We'd ask you to not do anything else, and we would see if you guys changed, because we have to have a control group in order to know, like, over time, does a certain variable change? Is there something about the fact that it's springtime, or something about the fact that it's winter or summer, right? Or you guys are walking around a bunch on campus that could have some other sort of an effect. We need to try to narrow down this idea that the only thing that is different, or that we're really able to kind of have, that's going to cause something, would be whatever our intervention is. Okay. When you guys see, my wife and I are anxiously awaiting, they're doing sort of randomized control trials on giving the vaccine to little kids that are my daughter's age. And the way they do all of that, the way they did it for the adult doses, was you get in these groups and they don't tell you what you're going to get, and they give you either the placebo or they give you the vaccine, and then they follow people over time and they see how many people in each group were getting COVID in that way. And then at the very end, once they've got enough people at enough kind of endpoints, then they tell you you were either getting the control, you were getting the placebo, or you were getting the actual vaccine. And then they look and see if there were some differences in those particular groups. And when you do drug stuff, when you do nutritional things, when you do exercise things like that, having controls and having placebos in some ways is of absolute importance. And so if some of you guys pick or land on your experiment where you need a control group, I'll talk with that group a little bit more about how we're gonna try to do all of that. Okay. This stuff is really a little less pertinent in some ways, I feel like. Have you guys heard of the word qualitative research? Anybody know what qualitative research is? Are any of you in health promotion program planning? Let me ask that. Nia, you said you know what qualitative research is. Can you maybe give us a little more of an explanation there? Okay, there Nia's back. We've lost Nia.
Okay. So it's like questionnaires and like stuff like that, because quantitative is, I think it's like some stuff that's already been found, and you go based off that. I mean, I don't know, something like that. But
okay, yeah. You're barking up the right tree in some ways, as we would say in Arkansas, on all of that. Everything that you guys have proposed to do is what I would call quantitative research. You're going to get numbers at the end of things. Okay. You may get some things that we're going to have to artificially give numbers to, like, even if it's like a Likert scale or something, when you're going to ask questions about, do you sometimes, never, always, or things. Okay. Qualitative research is done by doing interviews. You're asking people their thoughts on something. You're asking people their feelings on things like that. Okay. More of the way that we are doing, you guys probably maybe filled out the student teacher evaluations for your professors last semester. There's a little less of like, yes, I'm going to give you a 1, a 2, a 3, or 4, or a 5 out of this, and more emphasis placed on, tell us about the things that you think they did well in class, or tell us about how well they, or they did these kinds of things. And that's a little bit more what qualitative research is. Qualitative, you focus oftentimes on a smaller group of people that have certain characteristics and really, really try to go in depth with them. Okay. So, we would do things like, we would ask Ashley, tell us your feelings about, I don't know, whatever your favorite TV show is. Like, let's dig in on whatever that's going to be. And then you ask a bunch of people the same questions, and then you see, are people telling me similar things? Are there themes that are going to kind of go through all of this? And then when you present that research, you describe it. You just kind of say, here was what people were saying, as opposed to, Ashley thinks that Friends is an 8 out of 10, and Bailey thinks it's a 7 out of 10, and she thinks that Ross is the worst character in the world, and blah, 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 all of those kinds of things. Okay. So most of what you guys are going to do is quantitative. We have several researchers in our department that do really, really good qualitative research. And sometimes people come off with what I think is the mistaken impression that somehow qualitative is lesser than quantitative. And I would argue very strenuously that they're just different. It's just different ways of approaching and getting different kinds of information. We can learn lots of things from both, and in a lot of instances, we can find some things quantitatively and then really dig into them qualitatively to try to get a better understanding, especially when you're dealing with sort of human behavioral things, right? Attitudes and behaviors, and like, why do you act in the way that you do is I think really something that can be explored with qualitative. Okay. All right. So let me zoom back over like this. Basic and applied. This stuff is all that part of stuff is pretty straightforward. Okay. Descriptive versus experimental. So these are two things, a lot of what you guys are going to do is going to be a combination of descriptive and somewhat kind of quasi experimental. When we're just kind of doing a lot of survey things, we're just describing what a population of people look like: age, height, weight, how active they are, how many times they exercise, kind of the other things, what, that you guys had looked at. A lot of that is kind of considered descriptive. Okay. And you use the descriptive stuff to look for relationships. We talked a little bit about experimental, but some of you guys are going to get at some things. It's like, hey, have you done this? Did this happen? That may be a little bit more that way. Other big things to kind of keep in mind, for the most part, it looked like all of the stuff you guys were proposing is what we call cross-sectional. And cross-sectional research means we're going to grab a bunch of people right now at this one particular point in time and do something with that particular group. Okay. They may have different characteristics to some extent. Okay. And we're gonna kind of see what's happening in that group of people right now. What do they look like? What are their characteristics and things? Whereas longitudinal is a little easier for us to find cause and effect, but it's also sometimes much more difficult to do. Is where we get a bunch of people and we follow you for some stalkerishly long period of time. Okay. And so I think in my 3813 class, I talk a little bit about something called the Harvard Alumni Study, which is a very famous study that looks at we have a lot of information on tracking people over time and what it is that causes sort of health disparities and those kinds of things. That's a longitudinal study, right? You guys graduate from our department this year. We have you fill out a questionnaire for us. And then every year, basically until you die, we send you the same questionnaire and you give us information. And some poor researcher 50 years from now can then use y'all's data to kind of look at, okay, well, the people that did this lived longer and the people that did that tended to make more money, or whatever that was going to be. That's longitudinal research. Okay. This part doesn't really matter too much. We hit on kind of the components of your capstone project to some extent the other day. We'll get into, and we'll have separate days where we just lecture on kind of what we do in each one of those things. Okay. So I know that was fast. All right. But you've got the PowerPoint, and a lot of the stuff is I think pretty straightforward. Okay.